The Higgs boson. The Higgs boson is an elementary particle in the Standard Model of particle physics. It is a quantum excitation of the Higgs field, a fundamental field of crucial importance to particle physics theory, and suspected to live in the 1960s, at least first off, which, unlike other known fields such as the electromagnetic field, takes a non-zero constant value almost everywhere. The question of the Higgs field existence has been the last unverified part of the Standard Model of particle physics, apart from some real abstract parts such as the graviton, which aren't as substantial in certain aspects. But it is thought to be the central problem in particle physics. The presence of this field, now believed to be confirmed, explains why some fundamental particles have mass when based on symmetries controlling their interactions. They should be massless, but the existence of the Higgs field would resolve several other long-standing puzzles, such as the reason for weak forces in extremely short range. Although it's hypothesized that the Higgs field permeates the entire universe, the evidence for its existence has been difficult to obtain. In principle, the Higgs field can be detected through excitations in the manifest of the Higgs particles, but these are extremely difficult to produce and detect. The importance of this fundamental question led to a 40-year search and the construction of one of the world's most expensive and complex experimental facilities to date. CERN's Large Hadron Collider, in an attempt to create Higgs bosons and other particles observation and study, has been created through the search for the Higgs boson. On the 4th of July 2012, the discovery of a new particle massed between 125 and 127 GeV divided by c squared was announced. Physicists suspected that it was part of the Higgs boson. Since then, the particle has been shown to behave and interact and decay in many ways the predicted Standard Model. It was also tentatively confirmed that even partial zero spin, two fundamental attributes of the Higgs boson. This appears to be the first elementary scalar particle discovered in nature. More studies are needed to verify that the discovered particle has properties matching those predicted for the Higgs boson by the Standard Model, or whether, as predicted by some theories, multiple Higgs bosons exist. Some theorize that there might be even different flavors of Higgs boson that live within the range of the Higgs field, unthought of and undiscovered, and even unsearched for, as we're always looking for the one thing that we have our minds set on. Well, the Higgs boson is named after Peter Higgs, one of the 6 physicists who in 1964 proposed the mechanism that suggested the existence of such a particle. On the 10th of December 2013, 2 of them, Peter Higgs and Francois Englert, were awarded the Nobel Prize in Physics for their work and prediction. Although Higgs' name has come to be associated with the theory, several researchers between 1960 and 1972 independently developed different parts of it. In mainstream media, the Higgs boson is often being called the God particle, from a 1993 book on the topic. The nickname is so strongly disliked by many physicists, including Higgs, who regarded it as a sensationalistic. In the Standard Model, the Higgs particle is a boson with no spin, electric charge, or color charge. It is very unstable, decaying into other particles almost immediately, as it's so heavy it is not be able to support by the minimal amount of energy provided by the colliders. It is a quantum excitation of one of the 4 components of the Higgs field. The latter consists of the scalar field with 2 neutral and 2 electrically charged components that form a complex doublet of weak isospin, SU, or unit symmetry. The special unitary system is only used with some special particles that have extreme mass or an extreme attribute. The Higgs field is tachyonic, which does not refer faster than light, has a Mexican hat-shaped potential and a non-zero strength everywhere, including an otherwise empty space, which the Higgs field are absorbed by the special unitary unit 2 and 1. The gauge bosons, the Higgs mechanism, to become a longitudinal components of the now massive W and Z bosons of the weak force. The remaining electrically neutral components separately couples with other particles known as fermions via Yokowa coupling, causing these acquired mass as well. Some versions of the theory predict much more than one kind of Higgs field and bosons. Alternatively, Hilus models may be considered if the Higgs boson was not discovered. On the 15th of December 2015, two teams of physicists working independently at CERN reported preliminary hints of possible new subatomic particle. More specifically, the ATLAS and CMS experiments using a 13 TeV proton collider data showed a moderate excess of around 750 GeV in a 2-photon spectrum. If real, the particle could either have been a heavier version of the Higgs boson or a graviton. I'm going to leave the video here. If you liked the video, be sure to like and subscribe, and as always, thank you for watching.